So this is a log from my last run up at Salem Saturday night, and I have, well, last time I was up there on a hard tire, I let it have 15 pounds in fourth, but now I'm on slicks and life is much better. I let it have a target of 15 in third and fourth. I'm getting up touching 16 pounds. So I was looking at the data afterwards, and first I noticed my duty cycle was getting up there rather high, and at first glance I was like, well, might be running out of injector soon. But taking a closer look, I saw that my fuel pressure was actually dipping, and once I get up in the 15-16 pound range, it's steady decline. And then when I kick the clutch to change gears, I'm using two-step to cut ignition, and I'm dumping some extra fuel at it, so it really sucks it down there. It got all the way down to 30. So it is time to turn up the fuel pump a little bit. I've got a Fuelab variable speed brushless pump, and I've just been running it on the low setting just all the time, but it seems I've found the point where I need to ramp it up a little bit, so working on that now, and it appears I have some help. So I'd planned, the fuel pump and the fuel system was one of the first things I ever bought. Actually, might have been before I even decided to go Fueltech, but I really like the idea of having a variable speed pump and being able to run it low when it's not needed. And so I had the wiring there all along. I just didn't need to take advantage of it yet. But I removed the jumper to keep it on low speed and landed the wire I'd ran originally for the pulse width modulation, and set this generic duty cycle control up. Not 100% sure how I'm going to do it, and it seems it will only let me put a max frequency of 300 hertz. The Fueltech stuff says 500 to 1500, so I'm not 100% sure on that yet, but I think it'll still work out. So I got that set up, and just for testing I got a map-based duty cycle, 80%. So I wrote that to the computer and kick it on, and it's got a setting for progressive. It's pretty loud, high speed. Got a setting for progressive off the throttle. So you can hear it. The only thing is, it's kind of reverse, and that is because when it's not putting out any duty cycle, the fuel pump is thinking it's calling for high speed, because if you ground it with a jumper, it's low speed. Not grounded, it's high speed. So I don't have any spare yellow outputs. I can only use a blue output from the Fueltech, so I might have to do it kind of backwards per se. I could always use that output. I could just wire it up and use a generic output, and rephrase that. I thought I could just use a generic output straight to it and just have it turn on at either a certain RPM, certain map pressure, certain whatever. But there's not a whole lot of settings for generic output, and even if I could, being it's not a yellow wire, I can only do activated at 0 volts, so that's not going to work, because unless I did it like inverse, and I don't even know if I could do that. If I could make the output on below a certain RPM and pull it low, maybe I could do something like that. I could always tie it into a relay, of course, and just, inverse it through the relay, and that would work. But I'd really like to use a pulse width, so I'm going to play with it a little bit and see what I can do. It seems 60% it'll still run, 60% duty cycle. 80% it was shutting it off. Let's try 70. See what it does. Okay. It still runs, but it doesn't sound too healthy. So it might have to be 60%. It's a lot narrower window. I'm going to assume that's because I can't give it the hertz at once, but we'll see. I've got it on 20% generic duty cycle there. When I 20% duty cycle, doesn't change the pump speed, so that's still full speed. So 30% did. I might try 25%, but 30% did drop it just a little bit. That's the starting point. I misspoke again. It was not 30%. 30% did not change it, but 40% does drop it down a little bit. So somewhere between 30 and 40% inversely would be max fuel pump speed. So might try something like this. I don't know. There's quite a few ways to do it differently. But one last test. So we're setting at 0 right now. Obviously, we just throttle cuts it down. One thing I do want to compare is the speed. Compare the speed of that 60% duty cycle to the actual hardwired low speed setting, and just because I kind of like that to just be the low speed setting what it has been running, and at least I shouldn't have to play with my fueling too much there. The regulator will take care of most of this also. I'm going to go here and I'm going to turn this progressive output by TPS off, and sure make that where it's just a program value all the time, hopefully. And I'll write that, and then I'm going to run it and compare the speed it's running at 60% to just hardwired jumper. We'll do this, and it is quite apparent that the low speed a little bit faster than this setting at 60% pulse width, so we'll adjust that a little bit. So I changed to 55% pulse width. It's very little difference. Going off the log, the sound, I mean, by sound there's very little difference, but according to pressure it wasn't. Of course, can't forget about the regulator, but I think that's where I'm going to leave it as far as at idle, anywhere below 10 pounds of boost, and we'll see if anything's wildly off, and then go from there. This is interesting, and it might be a good thing, but I hit the clutch, like it turns on two-step like I'm gonna launch, and I hear the pump back there really ramp up. So that's interesting. Again, usually if you stare at it long enough, you'll figure it out. Every time I push in the clutch, which considered two-step on once I mash the gas, but clutch switch, clutch position, two-step on, my fuel pump was ramping up, and wouldn't be a big deal, but there's actually a solid 4 plus almost 5 pound difference at idle, and I'd say that's just because the size of the regulator is a little smaller, but I didn't know why. And then I come over here, generic duty cycle control, that right there's why.